So there we go, we're on the final part now. They're ready. So if you can do these, you're exam ready. So below is a right angle triangle and a rectangle. The area of the right angle triangle is equal to that of the rectangle. So calculate x. Right, so the area of this then, so the area of a triangle was your height times your width, then divided by 2. So actually it's got 13 there, but I don't need that 13, so I'm just going to scrub it out for now. So the height of that would be 5 times 12 divided by 2. So 12 times 5 is 60, divided by 2, that gives us 30. So the area of that is 30. So we can put that into equation if we want and say 10x, so 10 times x gives us 30. So 10 times something gives me 30, so 10 times 3, so x is going to be 3. Right, so this diagram shows a semicircle inside a circle. Write down the ratio of the radius of the circle to the radius of the semicircle. Right, so the radius of this is 10 centimeters. So we'll have radius of circle of 10. Radius of the semicircle, that's the smaller one, it's not 8, it's going to be half of that, isn't it? So it's going to be 4. So 10 to 4. So ratios need to be simplified. So if I simplify that, we get 5 to 2. I think that's all the question's asking me to do. It's quite straightforward in the end, actually, but yeah, that's it. So question 3. Here's the net of a cuboid. So the net shows the area on each of these faces. So work out the volume of the cuboid. Right, okay then. So we know that's 20, so we know that's... So what we need to do then is we need to work out the height of it, also the length of it and the width of it, because then the area, the volume is going to be height times width times length. So if we just look at these numbers then, so thinking about this one here, so that's 20 centimeters, so the area of that is 20 centimeters, so it's going to be made up of two numbers that you times together to give me 20. So just in my head I can think, right, it could be 2 times 10, but it doesn't look like it could be because that won't be so suitable with this one. So I'm going to just try having a width of 4 and a height of 5. Yeah, so that 5 times 4 will give me the 20. And then if I look at this one, so that's now got to be 15, and this is 5, that would make this 3. So think about a cuboid, so if that's 3, this is going to be 3, and also that's going to be 4, so actually that would get me my 12 as well. So that would be 4, and then this one would be 3. So I've done some thinking there, thinking out loud, to try and work out what the length of the cuboid is, what the height of it, and what the length of it, or what the width of it is. So the height is going to be 3, so that'll be 3. This will be 4, and that'll be 5. So 3 times 4 would give me 12. 12 times 5, we've got a volume of 60 centimeter cubed. Alright, so yeah, last question. So here's a drink container and a lunchbox. So the drink container is a cuboid with a square base. The area of the base is 25 centimeters squared. The volume of the container is 400 centimeter cubed. Will the container fit inside the lunchbox? Right. Right, okay then, so volume is your height times the width times the base, right? So the base of this, height times width times length, the base of this is 25 centimeters squared. So we know the volume of that container, that drinks box there, is 400. So what we'll do is we'll do 400 shared by 25 So we do 400 shared by 25. That gives us 16. Right, so it's got a height there of 16 centimeters. 16 centimeters. Now this is a square. It says there the base is a square, which is 25. So therefore the length of it is going to be something times itself to get to 25. So it's going to be 5 and 5. So the question is, will it fit in this lunchbox? So it's 12 and it's got a height of 16. So it won't fit upwards, but it will fit across because it's only 16 compared to the 20. And also it's got a height of 5, so it'll fit up to there. And a width of 5 as well, so it'll fit there as well. So the question is, will it fit in this lunchbox? And I've tried to draw it on roughly where it would sit, but yes, it will. It'll fit in there. So you must show you working out. So the working out is basically here we've got a height of 16 and then a base length of 5 and then a width of 5. So 5 times 5 times 16 would give us that 400 centimeter cubed. So yes, it does.